Hi, this is Pratik and welcome to Code Verify. In this video lesson, we're going to learn about breadth first search in a graph. To do breadth first search, you need to understand what is breadth first traversal, else that's how you're going to perform breadth first search. Now, breadth first traversal is that you can move to the next level only if you have traversed all the vertices present at the present level. If I show you this through an example, then let's suppose that this is the graph that has been given to us. Now, breadth first traversal would mean that first you start from the root, then after you have traversed the root, you traverse all the vertices that are adjacent to the root. Okay, so the vertices that are adjacent to the root are 1 and 2. If I say that the root is present at level 0, then the adjacent vertices of the root are present at level 1. Similarly, the adjacent vertices of level 1 are present at level 2. Now, breadth first traversal would mean that first you complete and traverse all the nodes at present at level 0. Then once you have got that, then you traverse the nodes of the next level. That is, after you have traversed 0, you traverse the adjacent vertices of 0, that is 1 and 2. And after you have traversed 1 and 2, you traverse the nodes present at the next level, that is level 2. So you start from 1, you traverse 3 and 4. If 2 had any adjacent vertices, then you would have traversed that also. Now we're going to solve this by making use of adjacency list representation of a graph. Now the adjacency list of this graph would look like this. So this is a dictionary in which 0 is connected to 1 and 2. So 1 and 2 are present in a list, and similarly 1 is connected to 0, 3 and 4, and 2 is not connected to anything, so the list corresponding to 2 is empty. 3 is connected to 0, so 3 is connected to 0, so 3 has 0 in the list, and 4 is not connected to anything, so similarly 4's list is empty. So this is the key, 0 is the key, and its value is this list. Similarly, 1 is the key, and its value is this list. So we're gonna have this as a key value pair. Now to do breadth first traversal, we're gonna have to use a queue. So if we perform the breadth first traversal starting from the root node, then first we're gonna traverse the root node. So after traversing the root node, I am gonna append the root node inside this queue. Now since I have traversed all the nodes present at level 0, so now I'm gonna pop from the front of this queue. Now since the popped item is 0, so I am gonna look at the value present for the key 0. So this is the key 0, and the value present for it is this list. So I'm going to look at this list containing 1 and 2. Now in this list, the first element is 1, so I'm going to traverse 1 first, and I will append 1 at the end of this queue. Now I will traverse the second element of this list, that is 2, and append that inside the queue. Now since we have traversed all the vertices present at level 1, and which means that I have traversed all the elements present in this list, which means we have already traversed level 1, which means I need to go to the next level. So now I am going to pop from this queue. So the popped item is 1, therefore we can look at the list that is present for the key 1. So this is what 1 is connected to, 3, 4 and 0. So if we see this list, then we must first go to 0, but we have already traversed 0, so there's absolutely no point of traversing it again. Now to prevent us from moving to 0, we're going to create a memory of all the vertices that we have already traversed. So for this, I'm going to take the help of a list, and the length of this list will be equal to the number of vertices present in this graph, that is 5. And this list is going to contain a boolean value of false by default, signifying that none of the vertices have yet been traversed. So we're going to start from the beginning. So we're going to start our breadth first traversal from the root node. So first we traverse the root node, and after traversing 0, I am going to append this 0 inside this queue. And this 0, 1, 2, 3, 4 are the indexes of this list, and 0th index means Initially it was false, signifying that the vertex 0 has not yet been traversed, but now since the vertex 0 has been traversed, so I'm going to change this false to true. So after traversing 0, we have traversed all the nodes present at level 0, so therefore we're going to look at the adjacent vertices of 0. So look at the in order to look at the adjacent vertices of 0, we're going to look at the list that is corresponding to key 0. So this list is having elements 1 and 2. So first I am going to traverse the element 1. And also remember that I can look at the adjacent vertices of 0 only when I have popped 0 from this queue. That means after popping 0, you get to see what is the list that is corresponding to the key 0. So now we traverse the first element of the list, that is 1. And then we append 1 inside this queue and change this index 1 to true. And now this true would mean that 1 has already been traversed. So now we're going to look at the second element of this list, that's 2, and we're going to traverse 2. And then we're going to append 2 inside this queue and then change the second index of this list to true. So after traversing 2, we have finished all the elements present in this list, which means we have traversed all the vertices present in level 1. So now I'm going to pop from the front of this queue. We see that that element popped is 1, and the value corresponding to key 1 is this list. So we're going to traverse every element present in this list. So first we traverse 0, but we see that the 0 present in this list, it is already true, which means it has already been traversed. It is already true. So we will not traverse it again. So before traversing any vertex, we're going to look at this list. We see that in this list, the 0th index is true, which means we have already traversed the vertex 0. So we are not going to traverse it again. So this helps us from going to 0. So now we won't go to 0, we will go to 3. So now we traverse 3. So after traversing 3, we append 3 at the end of this queue, and then we change the index 3 value of this list from false to true. So now we traverse the next element present in this list, that is 4. Push that inside the queue and change its corresponding value of this list from false to true. So we have traversed all the elements present in this list, which means we have traversed level 2. So now we will again pop from the front of this queue. The popped element is 2, so we're going to look at the value corresponding to key 2. So the value corresponding to key 2 is this empty list. So since this list is empty, signifying that 2 is not connected to any other vertices, so we are not going to traverse any other vertex because 2 doesn't have anything in this list. So therefore we are again going to pop from the front of this queue. So the popped item is 3, and we look at the value present for the key 3. So the value present for this key 3 is this list having 0 as the element. So again, before traversing 0, we're gonna look at this list. Inside this list, the 0th index is already traversed because it's true, so we are not going to traverse 0 again. So this helps us from going to 0. So since 0 is already traversed, so we are not going to go to 0. So again, we're gonna pop from the queue. The popped element is 4. We're gonna look at the list corresponding to key 4. So even that list is empty, so we are not going to go to any other vertices, which means we finally come to the end of this dictionary, and we have finally popped all the elements present in this queue, and there is nothing left to be popped. So therefore our overall loop exits, and we have finished the entire process of breadth first traversal. So this is how we can do breadth first traversal. So now let's have a look at the code for breadth first traversal. First, I'm gonna import default dict from collections. So this is how we import modules into our code. So we're gonna use default dict in the later part of this code. So now I define a class graph, and inside this graph I'm going to define a constructor, and this constructor will be taking parameter as n. This will be given as input by the user, and this n will signify the number of vertices present in this graph. So it's essential for us to give the number of vertices present in this graph, because that's how we gonna know the length of this list. So remember that we created a list for keeping a memory of all the nodes or the vertices that we have traversed. So this is that n, which is the length of the list or the number of vertices present in the graph. And we're gonna set that n to a variable called numVertex, and we're gonna access that numVertex variable by using the object of this class. To represent our graph as adjacency list, we're gonna make use of this default dict that we have imported. So I'm gonna say self.graph. So this graph is the dictionary, and this is the default dict usage, in which we say that whenever we create a key for this graph, a default list or a default empty list will be generated corresponding to that key. So you will understand this later when I explain you everything. So for now, just move ahead and just remember that whenever we create a key for this graph, an empty list will be created as a value for that key. That's it. That is basically the use of this default dict. So now I'm going to define a function called addEdge, and this addEdge function will actually add edges into this graph. So this uv basically means that add edge from u to v. So this is actually a direct graph, because remember that in my graph I showed you everything as arrows pointing from u to v. So now I write self.graph u.append, which means graph u is actually the key. So u is actually the key, showing that there is a connection from u to v. So whenever I say self.graph u, and this graph is actually made by using the default dict, which means whenever I say graph u, which means automatically an empty list is generated for the key u, which means even if I had written self.graph u, then an empty list would have been generated for this key u, and inside that empty list I would say that append v. So a configuration similar to this would get generated. So this u is the key, and this v is present inside this list, which is the value of this key u. So now I'm going to create the graph structure. For that, basically I am going to define the object of this class, and this definition we pass the value 5. That is nothing but the value of n that I assigned for denoting the number of vertices present in this graph. Then I make the various connections of this graph. That is, there is an edge from 0 to 1, there is an edge from 0 to 2, there is an edge from 1 to 3, and so on, so that this graph gonna look exactly same as I showed you in the example. So this is it. There is a connection from 0 to 1, and this is a directed graph. So this is an arrow showing that if I say that this is u and this is v, then there is a connection from u to v, and that has been shown by using an arrow. And so similarly you can see that there is connection from 0 to 1 and 2, then 1 is connected to 3 and 4, and so on. This is exactly the same. So whenever I call this addEdge function in the main, a similar structure will be formed as a dictionary. So similar values will be contained in that dictionary. So now we got that dictionary, since I have called this addEdge function inside this main by using the object g. Now to breadth first traversal, I am going to define another function called BFS, and this s here is basically the root from which I am gonna start my breadth first traversal. And remember that at the start of this traversal process we have a list which is going to contain a value of false by default. So this is the list, and this is the list called visited, and it's going to contain the value of false by default. So therefore a list of length of size 5 gets created, and all the indexes present in this list will have a value of false by default. Now I declare an empty queue, and then I traverse the root node and I append the root node inside this queue. And after this appending, I change the value of the root index present inside the visited list visited, and visited s equals to 2, which means that the index s present in this visited list will get changed to true, signifying that the node s, which is the root, has already been visited. And after that, I'm just going to print s. So now I'm going to pop from the list from the front of the queue, not list. I'm going to pop from the front of this queue. So the popped element is the root s, and this 0 here basically represents that pop from the front of this queue. So now we're going to have to look at the list corresponding to the key v present inside the dictionary. So for that purpose, to look inside that dictionary and traverse all the elements present inside this dictionary, I'm going to make use of a for loop. And inside this for loop, I say for I in self.graph, saying that traverse all the elements present at the value, that is the list is the value present corresponding to the key v. So I'm going to traverse all the elements present inside that list, and then I'm going to say that if visited I is equal to false, that is the first element encountered, if its index present in the list visited is false, then similarly append that inside the queue and mark it as true. So this is what we did. We appended inside this queue and marked the index I present in list what visited as true, and then we print it, signifying that yes, it has been visited. For like, suppose I have visited all the elements present inside this list, and I visited 1 and 2, and I have appended 1 and 2 inside this queue, and also the indexes corresponding to 1 and 2 and 0 has been changed to true, signifying that they have already been traversed. So again, I will have to pop 1 from this queue, and after popping 1, I'm going to look at the value corresponding to key 1, and I'm going to traverse all elements present in this list. And after doing so, again I will change the indexes present of 3 and 4 to true, and again I'm going to traverse, again I'm going to pop, I've already popped 1, so again I will pop 0. So this is basically a while loop. So in my code, I'm going to say that I'm going to declare a while loop, and all these steps will be inside this while loop. Now this 1 signifies that this is a never ending while loop, which means we will have to give the condition for ending this while loop. So remember that I said that we will stop the entire process when the queue finally becomes empty, which means we have traversed all the vertices in this graph. So I'm going to say, so if the length of the queue is 0, signifying that the queue is empty, which means then we're going to have to break it. And then I'm going to call this BFS function inside the main function, and I am going to say here I call it, and I am going to print the graph that I created. So if I run this program, you see that the traverse nodes are 0, 1, 2, 3, 4. So this is exactly the result I wanted. First I wanted to go to 0, then I wanted to traverse 1 and 2, and then I want to traverse 3 and 4. This is exactly what is the breadth first traversal is. And here is the dictionary. So corresponding to 0, there is 1 and 2, and corresponding to 1 is 3, 4, 0, and corresponding to 2 is empty list, and so on. This is exactly same as I showed you in the example. So this is how breadth first traversal is done. And if you wanted to do a search operation, then you could have simply written here inside this for loop that if, like suppose you want to search for 2, you would have written that if the element is 2, then simply print that yes, 2 has been found. So you can do that for yourself. So this is what is actually a breadth first traversal, and using this breadth first traversal you do breadth first search. So I hope that you understood this video. Like and share this video and subscribe to the channel. Thanks for watching.